Wow, this is very scary.
Yeah, it's God speaking. Yeah, it's like
Yeah.
God of Zoom. I guess I should put this. Oh, I need to make it so you can share.
What are you doing? You're sharing screen here.
Yeah, I can.
Your
Yeah,
screen.
screen button at the bottom. You can share your screen.
You don't want to do that yet.
I just allowed it, so if you want to, you can try it. We got a few minutes.
Let me just try it, see if it works.
Yeah.
Well, I've got so many things here. That works.
Oh yeah. Okay.
Is that okay?
That looks great. Yeah. Yeah. I knew it. I began, and I think I shared my screen automatically, but I didn't. Oops.
I'll just turn me off for a minute.
Yeah. Yeah. So how are you doing?
Fine, thank you. All good. Yeah. How are you doing?
Good. Yeah. We're doing okay, I guess.
How
Yeah.
many are you expecting to join?
There's 50 kids in this class, so
50s. Crikey.
in the room we got like 10 or 12, and then I think supposedly, and I'm recording it, so I mean, I guess people will show up. The 10 or 12 that are here will ask questions, I think, hopefully. One of them requested you, so
Oh,
yeah,
all right. Okay.
I'll ask some questions too. So looks like you guys are doing a lot more. You've advanced quite a bit, right? I mean,
Yes, we go around in circles quite a lot, but yeah, it's growing.
what's your background is in architecture or something, or
Well, actually, it's in theatre.
okay, yeah, all right.
Primarily theatre lighting. That took me into all sorts of curiosities about light and what does light do and color and intensity and things. And I became a bit preoccupied with photosynthesis. How does that work? What sort of light does a lettuce need and why and how,
Yeah.
And that took me down this rabbit hole of photosynthesis, sunlight, energy.
Yeah.
So it's the same thing, just the other way around.
Yeah, it's pretty interesting. I guess if you're around the right people, opportunities arise, I guess. Yeah. It's pretty successful though, what's going on now. I mean, I noticed you have a couple of like Oman, some stuff going on in Oman.
We've got bits of stuff going on all over the place. It's not nearly as successful as it should be, but when you look at what the world does, then you think this is completely mad.
Yeah, yeah, it totally makes sense. I mean, especially if you're near an ocean, you know. Like I'm thinking in Palestine, you guys should have been there. You know, I guess it's kind of political, but if you guys were there, they would have a lot less problems, I guess.
Wherever there's conflict, there's always water at the root of it, somewhere or another.
Yeah, that's true.
It's not talked about because it's so obvious. But a lot of the friction between Palestine and Israel is about the River Jordan and land and aquifers and controlling water and all of that sort of thing. And it really breaks my heart how it's all panning out. But I'll come on to that. I've got one or two things in the presentation that I'll relate.
Yeah, I see your picture greening the desert. Actually, Israel could use the help, I guess, but I mean, they're doing reverse osmosis, I guess, on pretty large scale, but basically this is a lot simpler and cheaper. So you think that any kind of poor country, I mean, Palestine's certainly poor and they're certainly on the ocean, and they don't seem to be able to do much more with the ocean given the patrols that are out there and stuff. I mean, I guess they're limited how far they can go for fish and things.
I don't know why it is. I've come up with a few proposals for Gaza specifically, and they haven't got through. And I think, and yet we have this great, fabulous conflict now where the water's cut off and the power's cut off. And it seemed to me to be completely logical to have 100 different small desalination plants around the coast, and greenhouses and evaporative cooling, and just being self-sufficient in lots of little ways rather than relying on one big machine.
Right, and it's less of a target for one thing. I mean, especially
Exactly, yeah.
photovoltaic. Yeah, I mean, I think that the people that are actually communicating out of there now are all using like photovoltaic and maybe a satellite phone or something, I guess. So that, I mean, I'm wondering how these people are on a cell phone or something talking to news organizations.
They're prepared for it, and they've got batteries.
Yeah, I guess the batteries.
And there's lots of little generators around the place.
Oh yeah, yeah, that's true. Yeah. Anyway, it would be nice to work there, but it's so much liability with it that you wonder if you get shot trying to do it or thrown in jail or whatever. You know? I mean, it's definitely there. It's like it's kind of like it would be nice to be able to try to help, but you this is back in your mind. You're thinking like, is that going to ruin my career? Or, you know, I mean,
Hey.
especially people are being fired, you know, for this kind of thing. So it isn't even a joke. It's like it's pretty seriously people think about it. And it's unfortunate.
Yeah, sure.
So anyway, yeah, I guess we could just get started if you want. So Charlie,
Live far away. I think, Greg, you have to stop sharing screen before I'm allowed to.
let's see. You're allowed to share screens. I don't think I'm sharing.
I can see you. You're on my screen.
Yeah, but that's
You're not. Your screen is on my screen.
that's just a feedback to you. I think if you hit share screen, then you will share with us, and then your box will go. If you hit the green button, yeah, so we can see your thing.
Is that it?
Yeah, that's perfect. Actually, you just disappeared. So I'm gonna make you. I think I can make you appear.
That second option.
The second one? All right. Oh yeah, there, great, thanks. All right, yeah, we got you in a corner.
Yeah.
Your slides in the middle, so that's pretty good. So Charlie's you've been doing this for a number of years, right? But I mean,
Yes, 30 years or something. Yeah.
right, I didn't realize it was that long.
Yeah.
Yeah, so anyway, you're working with some engineers, so someplace, right?
Yes, exactly.
So who are the engineers? Because these are all chemical engineers, the people here. I think you're working with aerospace people, right?
Well, all sorts of people actually in different places, but primarily sort of mechanical engineering at Birmingham University and Aston University. But I'm all up for collaborating with brains wherever they are and wherever there's interest.
Yeah, we're definitely interested. And so I'll let you just go ahead, and I probably might interrupt a few times. But
yeah, no, feel free to interrupt. I've got, just tell me, we've got about an hour, is that right?
yeah, we can tell they'll start leaving at 3 our
Okay.
time.
I've got more slides than you want to see. I just stuffed a whole load together, so I'll get through them as quickly as I can, just to give you a flavour of the whole thing. And I'll stop and shut up, and maybe we can have a chat if that makes sense. But the slide you're looking at now, that's a desert in Saudi Arabia, and the picture below is just 150 miles away in Oman, and it's green and lush because it benefits from a mist that blows in off the sea, off the Arabian Sea. And it's literally that. It's just humid air comes in and makes the place green. And how can we replicate that?
Tell them like Oman. So Oman's right next to Yemen in the top.
Exactly. Yeah. It's near the border with Yemen, a region called Salalah. I'll show you some more pictures of it.
Oman's a rich country though, right? Oman, I guess they have oil or gas or something. Somehow Oman is rich.
Oman has oil and gas. Yemen has oil and gas, but not so much.
I see. So anyway, Oman is a place Europeans go for vacation.
Yeah, it's a lovely place. It's a really lovely place. And it's somehow managed to keep out of all of the conflict and trouble that the rest of the Middle East has been involved in.
Several students from Oman in our chemical engineering program, you know, they're interested in petrochemical, I think. But so we have had
petrochemical. That's the main show in town. But I think they're beginning to pick up on this stuff.
cornered in with Yemen, which is like a hellhole right now. It's terrible.
Well, Yemen is just such a sad place. It's a country that, again, has drained itself dry. It's the wettest part of the Arabian Peninsula. And it has been so successful in agriculture that they've just drilled boreholes deeper and deeper and deeper. And they've, over the last 50 years, they've drained the entire continent almost. And so now nothing grows. And the groundwater, even around the coast, is saline, which again has something to do with the conflict there. But I'm just showing you now a very simple diagram of the simplest design that we've been able to come up with, which is essentially it's a Bedouin tent type of structure with a shade net over the top and evaporators at one end and evaporators at the other end to cope with the prevailing wind, which either comes from the left or comes from the right. Maybe you don't need both evaporators. Maybe you have a prevailing wind from one direction. But in most places, we find the two directions usually sorted out. And what it does is simply provides shelter from the wind, shade from the sun, and cooler air from evaporating seawater, which reduces the amount of water you need for irrigation by maybe tenfold, which means that the cost of that water, however you make it, if you're using desalination, is 1/10 of what it would be otherwise. Now, this blank screen isn't blank. It's a film, and it's only 1 minute long, and it's an explainer film, which I will... Oh, where's it gone?
Reforestation of deserts is a proven solution to climate change.
Do you hear that?
Here's how. We take seawater and pump it through our greenhouses. Some is turned into fresh water through solar-powered desalination to irrigate the plants, but most of it runs over evaporator panels. Warm, dry winds blow through the evaporators, making the air cooler and more humid. Cool, humid air substantially reduces the water needed by growing plants. Fresh produce can now be grown for the local market, and salt can be made from the concentrated brine. The cool, humid air doesn't just affect the greenhouse, but the downwind environment, creating oasis conditions. This simple and cost-effective approach helps restore the water cycle. What goes up must come down. Regreening degraded and desertified land over time and at scale. Growing forests capture carbon while growing food and empowering the local community. It's that water, a climate recipe.
There you go. That's about it. Did that come across all right?
Good. Was that in Somaliland, the picture?
That's nowhere. That's based on what we're doing in Somaliland. And it's also a sort of teaser for a project that we've been working on for Saudi Arabia, which is what you're looking at now. And what you can see is something most people don't see, and that's lots of rivers. It used to have a lot of rivers. It used to have a lot more rivers than it has now. And so now we're thinking a bit big. How can you restore that water cycle that was there once and increase precipitation and increase cultivation? Those two images I showed you to start off with, you can just see that's the map on the background there of the Arabian Peninsula. And right down at the bottom is a town called Salalah, bottom right-hand corner, which is in Oman, in a region called Dhofar. And you can see the mist, you can see the humidity, and it doesn't rain very much there, but it just benefits from this incredible mist. And you get this kind of landscape. This is all Dhofar. I mean, it looks like south of England, but it's extraordinary. The water cycle, as you probably won't understand this, but you get humid air comes off the sea, and that humidity is increased typically by a coastal plain and vegetation, and the wind then blows that humid air up a mountain range. And as it goes up the mountain range, it cools down, and there's a lot more rain on mountains than there is in the lowlands, and that rain trickles back and irrigates the vegetation. So you have a large water cycle from the sea to the land, and you have a small water cycle from the land to the land. But actually that small water cycle is much more important than the sea to the land. One, for reasons I can't really explain, but on land, around 80% of the rainfall we get originated from transpiration rather than from seawater evaporation. If you remove that vegetation,
that means evaporating from the ground. So
evaporating from plant, well, we call it evapotranspiration, which is everything. So evaporation from the ground, but mainly transpiration through plants. So if you remove that vegetation, that ground gets hotter because you haven't got plants shading it and cooling it. And plants are very good infrared reflectors. So the humidity that comes in off the sea tends to vaporize and doesn't fall back as rain. And this is the story in pretty much everywhere that is arid in the world. And this is what has been getting worse and worse over the last several decades. And what we're suggesting is we can restore that just by evaporating seawater and growing plants. And obviously it will take time and it's a slow process, but just as desertification happens through deforestation, overgrazing, and removal of plants, it can be replaced by reversing those processes. So just to recap, really, shelter from the wind, shade from the sun, and cooler air reduces freshwater use by plants by orders of magnitude. And if the plants aren't stressed by being too hot, they grow fast and you get higher yields. And as the plants grow, they themselves transpire water, which creates what we describe as the oasis effect, making it more likely that plants will grow upwind of the cultivation. To give you some idea, this is one location of the Red Sea. It's a place called Umloj, and this is a model. This is simulated from a simulation process we have. But what you see there in red is the ambient temperature in centigrade, and what you see in blue is what's called the wet bulb temperature. I assume everybody understands the wet bulb temperature. Do they?
yeah, you guys know.
I don't need to explain that. A lot of people don't. Essentially, it's the temperature you get when you put a wet towel over your head.
Supposed to learn that in thermal class. It's like, well,
Sorry?
okay.
We didn't have you.
Okay, they know what it is now, I guess.
Right. Good. Okay, that saves a lot of trouble.
It's got a wet sponge on it, and you get a different temperature from the evaporative. Tells you the humidity in the air.
The wind is obviously very important as well. And what I was describing in the beginning, where do you put evaporators? Well, in this particular location, that choice is made easy because there's a very strong prevailing wind from the northwest sort of quadrant. And what we've been proposing is that a large area, maybe 1,000 square kilometers of vegetation and evaporation in this region that's highlighted in green, which we can see actually from looking at Google Earth, used to be an agricultural region in the past. And you can see, looking at the mountain range, the Hejaz Mountains, where it has rained in the past because of all these valleys and erosion that's occurred. And the arrow is pointing to a place called Al-Ula, which is a very famous oasis in the mountain range, which is now extremely dried up. And there's evidence that once upon a time there were hippopotamuses and elephants in that region from ancient cave paintings. And of course they're not there now, but they couldn't have been there if it hadn't been a lot greener and wetter. So starting with, say, a hectare, scaling up to 1,000 square kilometers, evaporating, say, 10 million tons of water a day is a significant switch to the water cycle. And as they say, what goes up must come down somewhere. More evidence of the rivers coming from Al-Ula. And you can just see in the top corner here, this is one of the oases in that region, which is fed by rainfall from the mountain ranges. not very interesting. Rainfall in the Arabian Peninsula, this great big blue blob here where most of the rainfall is, this is Yemen. And it falls there primarily because it's the most mountainous. It has the highest mountains. But curiously, we ran the same model for Riyadh, which is a very long way inland. And because it's inland, the relative humidity is much lower. The air is much drier. And so the cooling potential is much greater, which makes you think maybe it would make more sense to evaporate seawater in Riyadh, take seawater to Riyadh, evaporate it, desalinate it, grow more crops, grow more plants, cool the city, rather than what they do at the moment, which is to desalinate it on the coast and chuck all the brine back into the sea. This, I'm sure you're all familiar with the concept of desalination. The simple diagram on the left shows that you take seawater, you put energy in, and you get fresh water out, and you get concentrated brine, which generally goes back to the sea. And that map on the right is actually the Gulf. And the red is high salinity. So all the countries surrounding the Gulf have been using desalination on a very big scale. Saudi Arabia is the biggest. They process 10 million cubic meters of seawater a day, and more than half of it is rejected back to the sea as concentrated brine, which accounts for all this redness here, which has the effect of killing off all the marine life, because once the salinity rises substantially above that of seawater, fish can't survive and most marine plants can't survive. And yet that seawater contains a huge amount of valuable minerals. Yes, seawater is salty and everybody knows it's salty, but if you break it down, seawater is roughly 3.5% salt, but those salts are primarily sodium chloride, but they're also everything else. And it's the everything else, well, salt is interesting because it's useful. And as you all know, salt is the kind of backbone of the chemical industry. But these other things, particularly magnesium and calcium, potassium, they're all potentially very useful fertilizers. I doubt whether you can read this, but it's a selection of the elements in the periodic table and their concentration in the reject brine that Saudi pumps back to the sea every day. And yeah, there's just fantastic potential for mining seawater for these valuable elements, but currently we're not really clever enough to do that. Again, you probably can't read this very well, but this is just a selection of minerals that are in solution in seawater at one solution or another, one dilution or another. And currently the ones to the right-hand side of this dotted red line are economically viable for recovery, and the ones to the left are more of a challenge. So this is one of the really interesting areas of future development. And I think it's chemistry and it's also membranes, and we're just not very good at making membranes currently. Not like plants, leaves, grass, humans, bodies, lungs, guts. You know, we're very good at, nature is very good at making membranes. Salt. Everybody says, well, what do you do with the salt? Well, the salt is used in all sorts of industrial applications. There's over 1,400 different commercial applications. Mainly, it's used in the chlor-alkali industry for making acids and alkalis and PVC and all of those things. And it is the backbone of all sorts of medical products. So just very simply, the story is that transpiration, this is our first greenhouse in Tenerife a long time ago, and it wasn't what we set out to achieve. Actually, we set out to find a cheap way of turning seawater into fresh water. But what we found by accident was that we were creating conditions where plants would grow where they didn't need very much water. So we really discovered, it took a long time to really figure it out, but by reducing plant transpiration, you can grow crops inside, which you wouldn't be able to grow outside, and you can grow them with much less water, much less transpiration than you would expect outside. This is a project in Australia we did around 2010, which everybody thought was completely nuts. This is on the edge of the outback in Australia. You can see it's very arid around the place. The vegetation in the foreground is all salt bush. It's growing on 100% seawater. We're right at the edge of the Spencer Gulf. And we managed to get really good results. So much so that it has now been expanded over 100-fold. And it produces, there's now 20 hectares of glasshouse producing 17,000 tons of tomatoes a year, which is roughly 15% of Australia's total demand. And that's what it looks like. It's entirely driven by sunlight, and we have a very elaborate solar field there, which produces heat. It's a thermal process, simply because the greenhouse needs heating in winter, because it gets down to 0 freezing temperatures in the winter. We use the heat for distilling seawater and turning into fresh water. And the heat is also used for making electricity. So we have 3 choices of how we use it.
So how is that funded? Was that the government funding or how?
No, it's private. It's private. It got some government grant, but it was a private group of investors. What I'm illustrating here is a CFD analysis of simulation of the effect of evaporative cooling. And we spent a lot of time looking at asking the question, is the wind sufficient to drive the process? Because if it is, it makes it very much simpler and more than half the cost. And the one on the left is showing a section through the greenhouse, and the wind is blowing from left to right. And this one over here on the right is a plan view, bird's eye view of the thing. And what's interesting from this is a box covered in net with the wind blowing through it and seawater evaporators on one edge. And you can see that the effect of the cooling and the humidification extends well beyond the greenhouse itself, which makes us think, well, maybe this is actually a bigger benefit than the greenhouse itself. This is the Somaliland project under construction. Top left is a close-up of the evaporators. Top right is our enthusiastic crew. Apart from our team, they're all local pastoralist boys who loved wearing goggles and putting on hard hats. And this bottom right is the desalination machine, reverse osmosis, small thing. And obviously on the left is the solar PV that drives the whole thing. And this was the concept. How do we use this simple oasis creating thing to create this idealized model farm here that will grow delicate things like salad and tomato and cucumber inside the greenhouse, and hardier things like citrus and fruit and vegetables and onions and things, using the benefit of the cooling and humidification that comes from the greenhouse itself. And proof of our pudding, this is our first harvest in 2018. Abdi Hakim looking very pleased with himself. He did a brilliant job. So we start thinking about what...
Like Somaliland's in the north part of...
Sorry, I can't hear you well.
Yeah, you should tell them, like, so Somaliland's in the north, across the Red Sea from Yemen, you know?
Immediately opposite, yeah, it's not very far away. It's the Horn of Africa, and it is probably... Somaliland is slightly disputed territory, but it's part of Somalia. Somaliland has declared independence, but it's a troubled area, which is probably the world's #1 conflict zone.
It's between Djibouti and Ethiopia. Like it's
exactly, yeah.
It's like a great place to work. It was a British colony once, right?
It was not so long ago, yeah.
The rest is.
Well, it was never a British colony. It was a British protectorate. It was called British Somaliland.
Yeah. So
And
anyway,
they've had a civil war with Somalia, and so we have a lot of Somalis in the UK from the diaspora. So there are a lot of strong connections between the UK and Somaliland. And this is just an image, a what if that the thing were expanded along these lines. And this could be in Somaliland, or it could be in Yemen, or it could be anywhere. Using this kind of approach of maximizing, this is a sort of traditional Middle Eastern approach to agriculture, where you've got date palms, which are as tough as old boots as plants, but they create shade for fruit trees and chilies and tomatoes and other citrus plants growing in their shade. And similar kind of approaches work in Australia and in Senegal, and it's just a very nice way of maximizing biodiversity, so that you can minimize the inputs and cost. A little bit closer to your home, we've been working on this concept with an engineering group called Engineering to Eden, and they've come up with a proposal to save the Colorado River, the Imperial Valley, and the Salton Sea, which you probably all know is drying up and causing all sorts of problems with dead fish and dead plants and high salinity and horrible smells and toxic dust blowing into Palm Springs and California in general. And their idea is very simply to drill a tunnel from the Salton Sea to the Pacific using Elon Musk's boring machine, a 12-foot diameter tunnel, because the Salton Sea is 150 feet below sea level. So it would fall in, it could refill naturally. Have I got the numbers right? 78-mile distance tunnel. And there's it's 230 feet below sea level. And that water could be used to restore the level of the Salton Sea and to reduce its salinity as a feedstock for the seawater greenhouse to evaporate it and take the salt out, so that it doesn't go on accumulating salt and ending up being a Dead Sea, evaporating large volumes of water, which will eventually come back as rain somewhere and maybe help to restore the watershed of the Colorado River. That's what it looks like in section.
so the Salton Sea was a man-made lake, right? Man-made sea originally.
Well, the Salton Sea has been a real sea and a dried up sea over millennia. And it refilled at the beginning of the last century because the aqueduct, the aqueduct burst its banks that was trying to draw water away from the Colorado River to the Imperial Valley, and it flooded, and they couldn't stop it, and so it refilled itself. But it has been a sea in the past. It sort of dries out and refills depending on over the millennia.
So it was almost like a diversion of the Colorado River, right? They took water.
Exactly. Yeah. I mean, it was once sea, I suppose, before the Rockies became so rocky. I don't know. And that dried out, and then over millennia it just refilled and dried out and refilled and dried out. And then this accident happened, I think around 1910 or something like that, when the canal burst its banks, and it was such a colossal flow that nobody could stop it, and it ended up becoming a sea again from this diversion from the Colorado.
So what's the quantity of water you're talking about? It must be a huge amount, right?
Yeah, colossal. Well, gravity fed 150 feet difference, 12-foot diameter tunnel. I can't remember the numbers, but it's really colossal. I have them somewhere, but they're just too big to even remember.
Is that going to go into your cellulose membrane? Cellulose?
Yes, exactly. So the idea is that if you just refilled the Salton Sea and left it there, it will evaporate. And if you kept filling it up, it'll just keep evaporating. So it will gradually get more and more saline and end up like the Dead Sea. And so by having seawater greenhouses in the vicinity, evaporating that water, we'll be taking the salty water out of it, evaporating it, and not putting the salt back in the sea, so that it will gradually restore its salinity to that of seawater. At the moment, it's about twice the salinity of seawater.
And you're going to get money from the government or something to do this?
This is just a concept. It's being looked at by the what have got, the U.S. Army Corps engineers.
Okay, all right, yeah.
And the Los Angeles water authorities and all of that sort of thing. It seems, from the little I understand of it, it seems to me to be a no-brainer, because the whole region has been drying out, and yet it has seawater on all three sides. There have been similar proposals to take water from Mexico, from the Sea of Cortez, and pump it uphill a little bit. And there are some areas here, there are some dried up salt lakes that are, again, below sea level. But this is complex because there's huge populations here, and it's a different country, and you've got boundaries and also. Whereas if you just put up a hole through the mountain with the boring machine, which is relatively cheap to do, I believe, it's something like $1 million a mile. It's not sort of outrageous.
That's like 80 miles, though, isn't it? Or
yes, 80 miles. Yeah.
Yeah, it's actually not much money. But then you're gonna have to have a valve on that too, right?
A big one, Yeah, but there's an opportunity for hydropower as well, and all sorts of things. So it's an intriguing concept, and there's obviously a lot of engineering to do, but we haven't yet managed to find any particular deal breaker that of unintended consequences. It can only be beneficial when you look at the alternatives. The Colorado drying out and drought.
I mean, if the flow of water, you could make electricity with the.
Exactly. Yeah, exactly. Yeah, there'll be enough head to do that.
So there might be some added benefit. It's a pretty interesting idea to try to do that.
Another one in Egypt we've been looking at. Egypt is, believe it or not, one of the driest countries in the world. It only survives because it has the Nile going through it, which again, it is subject to all sorts of conflict between the different countries that the Nile goes through, because everybody wants more of it. But Egypt has an average of 10 millimeters of rain a year, which is the lowest in the world. But it has its own depression. It's called the Qattara Depression, which is 200 kilometers from Cairo. And the thinking is that this subject has been discussed for maybe over 100 years, because it's so close to the Mediterranean Sea. But the depression would be roughly the size of, if it was a lake, it would be roughly the size of Lake Ontario. And if it was filled up and have seawater greenhouses around it, we could, again, as with the Salton Sea, we could stop it becoming a Dead Sea by continuously removing the water at the same rate that it comes in. So if you have seawater coming into it and you take it out at that same rate, you will be able to increase the evaporation, obviously double, and make use of the salts and the water and the evaporation and all of those good things.
So in both of these, you have to pump the brine back, right? I mean, in other words, you're gonna.
No. The whole principle is that it's zero discharge, because every conventional desalination plant, or 99% of them, put the brine back in the sea, because membranes can't manage high salinity brine. So once the salinity of your feedstock is roughly double that of seawater, membranes can't handle it, so they reject it. And they also clog up the membranes and all of those good things. But in our case, it doesn't really matter. We're just evaporating it over cellulose pads. And they don't clog up. What they do actually is very slowly get reinforced by the calcium which precipitates onto the cellulose as calcium carbonate. So very slowly over time, we're growing seashells.
Salty seashells.
Well, possibly we could design them to be really structurally. I'll show you one after this chat. Possibly we could grow, lightweight structural blocks of calcium just through precipitation, which is basically what calcium is, chalk. So all sorts of good things could happen from this. And then finally, sorry, this is my last slide. I don't know if you're all fast asleep by now, but this is the last slide. This is a proposal that has been on the table for the last 30 years at least. And it's called the Red Dead scheme, where you take water from the Red Sea, which is down here. This is a satellite map, Gulf of Eilat or Aqaba, which is down here on the Red Sea, to the Dead Sea, which has been drying out. It used to be much bigger. It used to extend this far. Oh, sorry. All of this is kind of dried up Dead Sea. It's shrinking and it's evaporating fast. And of course, what this region needs more than anything, arguably, apart from peace, is more water, because a lot of the conflict, as we discussed earlier, is about water. This map on the left, all of this pink area here is below sea level. So there is huge potential for massive volumes of water, energy, hydroelectric power, and all of those good things. And this has been discussed on and off for, well, at least 30 years, and it hasn't got any further. Because I think all the countries in the region, Jordan, Israel, and the Palestinians can't agree, won't agree. So that's it.
Interesting. So maybe, do you guys have any questions about this thing?
Let me just show you. I've got a sample over here. Here we go. Can you see?
Yeah.
Can you see that? That's an evaporator. It's just cardboard that's reinforced. And this is one. Oh, where should I put it? I can't. There. Just can you see that? That's now covered in calcium. So this is gradually. No, I want to be over there, don't I? Gradually turns into seashell. We're not clever. We're not as clever as snails or sea creatures in making really strong shells. But if we were, this would be a wonder material. But you're all chemists. Hey, you should understand this stuff.
Well, yeah, I think that there's people looking at that, like the in other words, how do you make a seashell? There's people that work on that. In other words, you need certain proteins involved.
Yeah, it's not straightforward.
Well, it could be. I mean, it might be possible.
Yeah, it could be. It could be. I mean, I don't know how clever a snail is, but they've defeated us so far.
Why is it? Isn't it? Wouldn't it mostly be like sodium chloride, or why is it calcium carbonate?
It's calcium. Calcium precipitates either in crystals, which are either needle shaped and random, which is chalk, which hasn't very little strength. You can snap a piece of blackboard chalk in half. Or it lays down hexagonal platelets, which are a little bit like plywood, and there's a layer of protein between the plates. And that protein is like the glue in plywood that gives it resistance to cracking. So a seashell might be a millimeter thin, and you can't snap it. It's really, really strong. And they have, as you know, they have the most incredible structural shapes that really are miracles of geometry.
Yeah, I mean, even the calcium carbonate is, if you can sulfonate it, you can make basically a wallboard from it. You remove the carbonate, swap it with sulfate, and then that makes.
Well, this This could be a sort of wallboard.
Yeah,
In fact, when it was first invented, in Sweden in the 30s, I think, the guy who developed it, Carl Munters, thought that it would be a very low cost insulation material. He didn't realize at that time that it would be a superb evaporator material, but so it can be used for insulation.
yeah, it's pretty interesting. But I mean, there's so much quantity of that you would make, right? Or how long does one of those that material last before you have to exchange it?
We've had it going for 7 years maximum, and after that time it gets a little bit gets a bit scruffy. It gets a bit eroded by the wind, and gradually, if you do it continuously, it will clog up completely and become one solid lump of calcium, and the air doesn't come through. So, but again, you can play with that a little bit by altering the wetting and drying cycles and the flushing cycle.
You come in with seawater and then it evaporates, and then the calcium carbonate precipitates on the cellulose.
Yeah, there's less calcium in seawater than there is sodium chloride, but calcium is the least soluble, so it's the first thing to precipitate out.
Where the rest of the water evaporates, or where does all the other minerals go?
Well, they evaporate at different stages. So you take seawater and evaporate it, and the first thing that precipitates out is calcium, calcium chloride. The second thing that precipitates out is sodium chloride, and the third thing that precipitates out is magnesium, usually as magnesium chloride. And they all overlap a little bit. So depending on if you want very pure salt, you have to stop it evaporating before the magnesium starts evaporating, starts to form, if you see what I mean. But once you've got the sodium chloride out, and then maybe the magnesium chloride out, you're left with a very concentrated liquid. It's almost oily, and it's in the trade it's called bitters because it tastes bitter because of the magnesium, and that can actually be used directly as a fertilizer because it's got NPK, nitrogen, phosphorus, potassium, and a whole lot of other trace things which are useful for plants, so long as you get it in the right dilution with fresh water so that the plants can cope with it.
That's pretty interesting. It's got the phosphate and some other things. So you're almost doing a fractionation in this process, but that can see engineered. That process, these guys could do that.
Well, yes. I mean, it sounds easy. It is easy, and of course, you look at the sea, and it's the most wonderful hydroponic demonstration system on the planet. Everything just grows there, gets its nutrient from the seawater, and it recycles it and recirculates, and everything goes in big cycles. Replicating that on land is more of a challenge because we're still learning.
Yeah, it's pretty interesting. So you guys, no questions? Anybody?
Has everybody nodded off?
No, they're sitting here looking, but they don't have.
Like after lunch is always the doom time, isn't it?
Yeah, I don't know. Yeah. Anyway, all right. So I guess that's about it. Thanks for talking. It was really interesting. I think I find.
Okay. Very good. Good to talk to you all.
I guess they can, if they want to contact you, your email's on the webpage.
Yeah. Have you got it? I didn't put it up. It's charlie@seawatergreenhouse.com. But maybe, Greg, you've got it. You can circulate it.
Yeah, if you guys have any ideas about even locations where they can go, or like the Salton Sea idea is a pretty good idea. That's pretty nice.
Well, it would be nice to get your views on it. We haven't been able to find any negative reason why it could cause any damage, so long as it's properly engineered, obviously, and you put a sluice gate on it and all of those good things. I can only see benefits coming from it, but and it's quite a low cost thing to do as well, actually, when you in terms of water and solving that problem in the Colorado and Arizona, all the conflict that's happening because of farmers and
there's been a recent study on the dust and the health effects of the dust from that.
Yeah, that's a big time. problem. I don't know what the dust is, but it's toxic something or other, because there have been huge deaths of there've been explosions of fish and then they all die for some reason.
The fish die, people breathe in the air too. Apparently there's a lot of impact on that. The people about it anyway.
Yeah, I think all the birds in the region die as well from, I don't know, from eating dead fish. I don't know what it is, but it's a big time disaster.
I'm wondering where the money end of it is, like how you could turn that into a profitable enterprise, you know. In other words, you can get like Corps engineers would be interested because I think they built the canal that you're talking about originally, you know.
Yeah.
So responsibility for the
Yeah.
But
yeah, but you know, the problem was solved a long time ago with the Hoover Dam. But I don't think anybody thought, you know, nobody's going to invest in a Hoover Dam, are they? I mean, there's got to be a national state thing.
Right.
Yeah. Hoover Dam is a much more expensive solution than a tunnel.
Well, I mean, the land's pretty cheap right now, you know, so you could buy up the land and then sell it after greened up, right? But so there would be a profit. Doesn't possible to make profit from that. Land's pretty expensive. It's got trees on it. It's pretty interesting how you talked about the deforestation part too, and what an impact that has, because that's in Ethiopia. It's all over. I mean, someone was telling me about in Greece when they were a kid, in an island they used to go to, and it was lush and green. Then the people just chopped down the trees for firewood, and now it's a desert, you know. But basically, it's all over the world, like you said. People just don't think. They think a tree, you know, it's not that important. But it turns out.
Yeah, exactly. Well, one of the things that's inspired me. This is a classic book called Design for the Real World by Victor Papanek, who wrote it 50 years ago. And at the time of writing it, he said that Los Angeles now has more roads and car parking lots than it has vegetation, which was a shocking thing to discover at that time. But I think it'd be even more shocked to discover that the weight of human stuff now exceeds the weight of all natural biomass.
Mm.
So the stuff we produce, cities and concrete and buildings and cars and roads and all of that, if you weigh it, is greater than the weight of all the trees and elephants and grass and crop and plants and whales in the world, which is quite a tipping point.
Yeah. Yeah, LA is pretty funny. They almost have no public parks, but they have these huge golf courses in the city.
Of course, yeah.
Google Maps, you see a lot of green, but it's all private golf courses.
Yeah, keep out.
Yeah, keep out. So there is green there, but it's not. They almost have no, but they have a huge beach. I mean, the whole coast is public. But
well, the thing about seawater is it is unlimited. You can use as much as you like, and nobody's going to complain about sea level falling.
well, yeah. Somebody did mention that the other day, like sea level problem, but yeah.
Well, there's another economic driver. I mean, you know, if this were done at sufficient scale, it would have an impact. We've had part of sea level rise is actually accounted for by over abstraction of groundwater for irrigation. We've been you know, like India, Pakistan, Arabia, the Middle East, Australia, most of North Africa have been taking water out of their groundwater at a faster rate than it comes in, and it's measured in sort of cubic kilometers. I mean, it's a colossal amount. So much so that it has shifted the wobble of the planet. The planet now wobbles on a slightly different axis because the land mass of the northern hemisphere weighs less than it used to, which may or may not be a problem, but it is a colossal shift that has happened without anybody really noticing or thinking about it.
Yeah, all these things just happen, like the desertification of the Saudi Arabia you showed, and even the Sahara Desert, the growth of it. You know, I mean, people talk about rivers there too in the past, but
oh yeah, and not so long ago too.
So it's really pretty strange. You don't think about the little things add up. But anyway, all right, yeah. So I think everyone's ready to go. So I gotta cut off then. Thanks for sharing with us. It's really interesting stuff.
Good. Good. And so if any other thoughts, do send me an email or whatever, far away.
Okay, all right, yeah, thanks again, yeah.
Very good. Okay, all right then. Bye bye, everybody.